Hello guys, my name is Tanmay and I am a student of Masters in Computer Application from International Institute of Professional Studies, and I am currently in 8th semester, and I have came today for an assignment with a new assignment of mine, which is solving a question paper of theory of computation, which is our internal test, first internal test, and it is kind of tricky as well as interesting. So let's jump to the topics we are going to go through. Okay. So the first thing we are going through is the basic things that we need to understand about the theory of computation rather than theory of computation to solving these questions. Theory of computation is nothing just the computation means it is a combination of various things that are included in computation. As we know, compute something we need to go through various elements, various perspectives, various things that are needed to compute anything basically. Okay, so here we have to go through for the refers to the grammar, which means the grammar includes of various things, which are there are three sets basically. Not even three sets, there are only two sets and another community, which is the first set is set of terminals, which concludes of the things means like the objects or the things or something which we call it by. Okay, and there are another set which is called the set of non-terminals, which is basically the noun phrases or uh, the examples are given below. You can read it out from there only. Okay, so come back to the next topic, which is the production, means how a sentence or a non-sentence means anything is included or being made or product produced. So first thing that we can see is the sentence is how we can create or produce a sentence by using various elements. The elements which are required to create a sentence are, as you can see, noun, phrase, transitive verb, phrase, noun, phrase. Means these are the examples or the elements which are needed to produce a sentence, a noun phrase, or whatever we wanted to uh, produce. And there are various examples of it, like there is article. See, there is the article, there's the adjective, the noun, again, adverb, transitive verb, intransitive verb. There are various examples also. Okay, so we have our first question of the test, which is use the set of production to show that each of the sentence is a valid sentence. Okay, so we need to conclude whether it is a valid sentence or not. So, for example, the first question of ours is the happy hair runs. Okay, so we need to conclude it whether it is real or the sentence is valid or not. So let's just break it down. It means what a sentence consists of: a noun, phrase, intransitive verb, and phrase. Okay, and other thing is article, adjective, noun, intransitive verb, and phrase. So there are basic things, three basic articles which are needed, means the three steps to go through, means to check the three various things before concluding it. Okay, so when we go through this, we can completely say that there it has the as an article and other things as many, the here as a noun, runs as an intransitive verb, yeah, happy as adjective. So we can conclude that the happy hair runs is a valid sentence, is a valid sentence. Okay, so this is how we conclude. Okay, so we need to practice these kind of questions more and more. The next question we have is uh, the tortoise runs quickly. Okay, sleepy tortoise runs quickly. The sentence, it is a sentence, so we need to go through all these three conditions, or we call it the examples, which are universal. Okay, so when we go through that, we can conclude that the sleepy tortoise runs quickly because it has all the elements which are needed to be in there. Okay. As well as we have another example, the tortoise passes the hare. Okay, so as you can see, there are the three, basically four. There are four examples of universal examples of checking it out. Okay, uh, then we can conclude it that the tortoise passes the hare. And similarly, there is another example of it. We have a second question, which is construct a derivative for the sentences in questions. Here we have a question that the question is the happy hare runs, as we had previously. The sentence is noun phrase and intersect the and noun phrase and intersective verb. So noun phrase is what noun phrase is made up of article, adjective, and nouns. So there's article, there is adjective, and there is noun. Okay, so this is also a way to conclude a sentence or to create a derivation tree. Okay, to creating a derivation tree to conclude a sentence, whether it's valid or not, by a derivation tree is much more easier because we can see the flow and the elements which lie beside of what category. Okay, so that was our first example. We have another example as this, the sleepy tortoise. Quickly, we did it, so we don't need to go through it again. The tortoise passes the hare, we did it. And let's jump back to the third question, which is construct a phrase structure grammar that generates all signed decimal numbers consisting of a sign either plus or we can say positive or negative. A non-negative integer and a decimal fraction that is either the empty string or a decimal point followed by a positive integer where initial zeros in an integer are allowed. So what we are going to do is to categorize things. Means what does it consist of and what we have been given. So we have two things. Yeah, we got two things: the sign and the integer. What we got? Non-negative integer, which is another thing to consist to go through. But firstly, we need to understand the not the subclass, the main class of this. We have sign and integer. So we conclude firstly of the positive integer because we are going through the positive integers first because these are easy to take care of, whether it is asking for non-negative integer, but it is easy to assume the positive integers first. Okay, so we have two kinds of signs, positive and negative. Integers, what are integers? Integers are the digits with a sign. Basically integers are the digits with a sign, but you can call a singularly a sign also an integer if there is only plus sign, and we can conclude it as +1. Okay, so it is also again a integer. So it's just a hypothetical example and nothing else. So here is how we have positive integer, and positive integers have integers and non-zero digits. Means the positive has to be integer and a non-zero digit. Okay. So the next topic is the next point we can understand the positive integer and non-zero digit being integer. Then positive integer tends to integer and non-zero digits, which is also consists of integers. Then positive integers are tends to non-zero digits. Basically, what we are calling here is the positive integers are nothing but the non-zero digits, the digits which are not zero. Okay, and the digits are non-zero digits are, for example, I is a class and I consist of one because there is no zero. You can't see zero. Every digit which is not zero is a non-zero digit. Okay, so let's come to the another point, point it is. We have another question which is give the Becker-Snor form of the grammar. It is a kind of uh, form of a grammar which concludes it by in a short period of time as well as fluently. For example, the question arises as the Bacchus nor the sign there we can start it with sign decimal number, which is sign and decimal number are what decimal number. Some of the decimal numbers are integers as well. Okay, so firstly we don't need the number means we go for integer. We go for decimal numbers further. Means in future means after in the video, later in the video, sorry. So here we have another sign and integer, and we consist of positive integers. The signs we have are positive and negative. Integers consist of digits. Integers are digits. Digits which we have is there is no negative or non-zero digits, so we can call it 0, 1, 2. We get started from there. The non-zero digits are 1, start from 1, and the positive integers are integers, and the non-zero digits. Here another thing is non-zero digits, integer. These are the same type of question which we are going through previous, the same kind of tree. Okay, and we have another question. Give production rules in Vegas. Now consist of yeah, we gave it as, yeah, the question we did previously was kind of similar. The identifier which we have identifiers which is IC letters, and these are identifiers and IC letters which are concluded. Basically, this is what we concluded as. There is nothing different in this. So the IC letters which we have are A, B, C, D, means the alphabets we have in our English grammar. Then the another question is at least three but no more than six lowercase letters, one and six upper class or lower class letters begin with an upper class letter. So here is, I think this is how the question is solved, as I have told previously. You can take a screenshot of that. Yeah, this is how we solve this. Let's jump to another the next topic. There are four examples for you, so go for it. These are interesting as well. These are the four. Sorry, I have cough. These are the 4 points which we have to go through, and we did very well. Okay. So there are this is a very important topic. If you are interested in theory of computation and the elements of it, you should read this. The video will go for a very long time period, so I'll skip it. We have another question. Give production rules in Microsoft, the same as previous one, that generates all identifiers in the C programming language. In can identifier starts with a letter or an underscore. With the underscore, there is no underscore, but just assume that it's an underscore in that parenthesis. That is followed by one or more lowercase letters and uppercase letters, underscores, and digits. So how do we solve it? So we need to conclude firstly what it consists of. Identifiers, the letters, yeah, identifier symbols, and what are the letters? The letters, symbols. What consists of symbols of letters and digits? Letters, IC letters, UC letters. IC letters were what? Mm, the small kind of we call since our childhood, the small a, small b, and UC letters are what? The capital A and capital B, lower cases and upper cases. It's what it is. It's LC letters. Okay, I'm sorry for that. As I've said, I have cold, and currently I have a headache, and this is why I'm fluttering that much. Yeah, bluffing that much. Yeah. So now we can conclude that what are the digits here? 0, 1, 2, 3. These are things which we have. The second question is give production rules in extend brackets NOR form that generates all decimal numerals consists of an operational sign, a non-negative integer, and a decimal fraction that is either the empty string or a decimal point followed by an optional positive integer, optionally preceded by some numbers of zeros. Okay, so what we have, the numerals which are signs, non-zero digits, decimal sign, zero decimal, okay, non-zero digits, 1, 2, 9, and this is how it is done. Same question as we have done previously. This is also a type of question which is very interesting to solve. Uh, for each of these strings, determine whether it is generated by a grammar given for postfix notation. If it is, find the steps used to generate the strings: ABC, asterisk plus, XY plus, XY minus Z, XY, sorry, WXYZ, negative asterisk slash, dividend, ADE, negative asterisk. So how do we solve it? Firstly, we got their expression. What is the expression? It is the expression, and what we consist of the term, and add operator, means the term, and add operator. So the factors means the factor, multiplicational operator or mul operator, then add operator. We are just doing what? We are dividing it into categories to subjects, to elements. Okay, so what is it? What is factor? Factor A is identifier basically factors are the identifier. This is operator. So this is how it is converted into postfix notation. Okay, this is the postfix notation. B cannot be done. Yeah, cannot generated. It not was not generated. Then we have this. This is as similar as previous ones, same as it is. This is another question which is not so much different from the other ones, similar to the previous one. Okay. Backus nor as Backus nor yeah, postfix expression. Same as you can take a screenshot of this and check for check it later. Check it out later. Yeah, this is also the similar kind of questions which we have gone through. This is something which is very much interesting to go through. We have to construct a FA, PDA, and PM. These are kind of machines, or a machine is what? Yeah, please comment down below what do you understand by machine. Okay, I'll eagerly wait to read your comments. Okay, so what is an FA? FA is a finite automation. Okay, finite automation is what means it has to terminate at a certain amount of at a certain level of time. Okay, so this is the very basic definition of finite automation. Finite automation is the simplest form of automation. It consists of a finite steps, means it has to terminate at some point. Transitions between these states labeled with input symbols and design start and exit state. Okay, so these are some basic things. Yeah. The PowerPoint has concluded as the question mark sign, but these are nothing but they are nothing. Basically, these are the Qs. There he mm, representative Q not here. Q not Q1 Q2. Okay. Yeah. So the transition for the FA is as follows. The transition diagram is this. Okay, I have to do this, but the transition as follows. The FA transition follows from right here to here. Since the process is similar, the from 0 to 0, it comes to, if the value is 0, then it comes to 1, and if it goes to 0 or 1, then it gets 0, it will go to the Q1 process. If it gets the 1, it goes for the 0 1 0 property. Okay, if you have to search for a 0 1 0 property, if 1 was there, we repeat it 0, then we go through, then we get a 0. If we get a 0, we go for a Q4, but if we get a 1, we go for Q2. So we got 0 1 and 0 again. But if what there is also a probability, if the Q2 has another 1, then it will be 0 1 and 1. So it will get back to Q4, which will lead back to Q0. But it's not really important in this cases, because it is just the computation of 0 1 0. Okay, this is also the concept by which this diagram has been made. What is the push down automation? Push down automation is another type of automation. This FX extended with stack. Stack allowed it to recognize context-free languages. The PDA can I'm sorry. The PDA can be designed to recognize uh, as follows. These as follows. Okay. These are the basic things which we need to know about the custom automation. You can read it. These are the very basic and uh, not so much important, but yeah, these are important, but it will consume time, so I'll skip later. But you can read it later. Okay. So another thing which we have, which is important to know, is Turing machine. Turing machine, sorry. Turing machine is what? Turing. Alan Turing was a scientist which was very popular in this time, and he created a Turing machine, which is a more powerful model of computation. It can read, can write, and move on an infinite tape. Means it cannot, if it can be um, played for, it can create a loop. The TM for can be designed as follows. So what we have to do, if we have the stage of Q naught, these are the back right, back L, yeah, back left, right left. Okay, So this at the beginning, move to the right end of the input, scan left, scan left until 010010. Okay, is encountered. If this is the situation, then only move to the left. It was encountered. Reject. Okay, if 100 is encountered, move to the left again and replace 01 with blank. It will convert into 0. And move to the leftmost non-blank symbol. What is the non-blank symbol? This is 1. If the system gets 1 1, move to the left and repeat the process. Means we are completely getting back to the same position. Here, what we have to do, if the symbol is 0 0, move to the leftmost non-blank system. What will be that will be 1. If 0 0 or 1 1 is encountered after 0 1 is rejected, then rejected again. If the tape is blank, accept. Yeah. If the tape is means it doesn't have any other further steps to go through, then it will go to as blank and it will accept the procedure and it will end. But it can, if you convert it as the step as continuation or to not to terminate, it will go on as far as you want, as far as you won't turn it off. Okay. So the construct a TM that accepts the language 0 1 asterisk and 1 0 asterisk. It's not 0 1 or 10. It's 0 1 asterisk plus 1 0 asterisk. To construct an animation that accepts the language, it is this language, we need to design a machine that recognizes strings composed of either 0 or more. Okay? Zeros followed by one or more ones, or one or more ones followed by zeros or more zeros. Okay, here is a high level description of how the machine works. Okay, so first thing is we need to start by scanning the input tape from left to right, and the second step is if the turning machine encounters a 0, it should continue scanning to the right until it finds a 1. If you start by 0 0 0 1 0 0 1, and if you got 0 at the leftmost side, you will go to the right until you find a 1 or end of the tape. Until the end of the tape, if you have only zeros, it will terminate, but if you have one, it will continue to occur. If it occurs before finding 0, it should reject because the string doesn't match either of the pattern. Okay, as it gets the 1, it rejects because the string doesn't match either of the patterns. Okay, then the third is if the TM encounters a 1, it should continue scanning to the right until it finds a 0 or the end of the tape. If it encountered a 0 before finding a 1, it should reject because the string doesn't match entire of the patterns. It is another um, description of how to make it work. And the other thing, the last thing is if the Turing machine reaches the end of the input, it should accept if it has encountered at least one 0 and one 1. Otherwise, it should reject it. Okay, so that was our Turing machine working. Okay, so this is one of the example which we use to create the steps. First, this is something that you would understand by uh, the description also. So first we read it out first. Below is a more detailed description of TM's behavior. Start and means you can read it as much as you want. It is all yours now. You can take the screenshot from here. It is very clear to understand. We go to the next slide. So there are several states which you will need to understand. There are state A, B, C, D. Okay, you understand it very quickly because it's not an tough thing to understand. Okay, I'm moving forward because I have to finish this as soon as possible. Construct a PDA equivalent to a following CFG as stands to OBB and B tends to OS, which is 1s 0. Test whether 0 1 0 to the power 4 is a and if for to construct it PDA equivalent to a context-free grammar. Okay, context-free grammar. We need to follow some steps which are for each non-terminal symbols in a CFG, we create a corresponding state in PDA. we introduce a stack of handles, the push and pop operation during the parsing process, and we design transition from one state to another based on the rules of the CFG. Okay, what CFG is context grammar here. Okay, so the S tends to OBB, which was very clear. It has a table. I'll provide it in the description. B tends to the OS that we had it, and one S slash O. Okay? I'm mentioning all the steps here also, uh, and you can read it very clearly. Furtherly, I am here to tell you a quick thing, which is about the table, which counts how it works. States as B, inputs are 0, 1, 0, 0, 1, 0, 0. Okay, and the stacks are the sign, B sign, B sign, B sign, as B sign. These are the basic things. And then what is the new state? These are the means the states are accepted, the new states are accepted, and the new states are as below. Here is also the description of this. And for now, thank you for your time. I appreciate the opportunity to speak with you today. I love to talk to you guys. I need your support as well as uh, I'll come up I'll come up with similar kind of topics very soon. Thank you so much. Have a great day. Bye. Greetings to you all again. Thank you.